books. So welcome, Dr. Norgaard, and we are really pleased to have you here with us.
Thank you so very much for the invitation. I'm honored to be a keynote speaker at ICMPC.
So we'll just wait for a couple of minutes to have the video started.
Okay, I'm not sure actually if this, so Chris is doing the streaming. I'll do the video, I have it here. So
Okay.
that works. I should Chrome tab, share audio.
Good afternoon, good evening, or good morning, depending on where you are in the world, and welcome to this keynote presentation. I first want to thank the organizer of ICMPC and EPSComm so much for this opportunity to expand on the research based on this study about connectivity of brain functional domains during jazz improvisation. This keynote gives me an opportunity to provide some background. I'm going to go through a couple of older studies leading up to this to put the results from the new study in context. For my dissertation study done in the 2000s at the University of Texas, I interviewed artist-level jazz improvisers. What was new about it was that I interviewed them right after they had actually played as part of the study, and they sat in front of a screen where they saw a representation of what they had just played. And I asked them questions such as, why did you play that, and where did that come from? This allowed me to do a qualitative analysis . Good afternoon, good evening, or good first, but more importantly, it allowed me to attach those answers, so to speak, to notation of their improvisation. So I knew exactly what they were talking about because I had this video of them pointing to notation on the screen. The initial notation was approximate notation that I then later fixed and edited. What I found was it appears that artist-level jazz improvisers continuously plan ahead. I call this sketch planning, and this is a concept that we are going to see later on that becomes kind of important as it aligns with a theoretical framework suggested by Roger Beatty in or could align, in my opinion. It also appeared that they were constantly monitoring what they had just played. As for the generative strategies that they used, a key strategy they identified themselves was using this idea bank, this storehouse of licks, if you will, that they would insert in ongoing improvisation, sometimes note for note, and sometimes just part of a lick. And that is also going to come back, and I will talk more about that. Then there are some other strategies that are more rule-based, the harmonic priority strategy and the melodic priority strategy, and sometimes they described playing material that they had played before. Specifically, the sketch planning idea is interesting because it's such a high-level planning idea. So in this excerpt, Ron Westray, a trombonist that I interviewed, describes that he's conscious of the second chorus, but what's interesting here is that he's actually, at that moment that he says this comment, he's playing the first chorus. But he says in the second chorus, I'm conscious that I'm going to string more linear stuff together. In other words, the second chorus would be more dense, which is what you can see in this transcription. Another thing that came out in addition to these was that in addition to these themes that I just mentioned, was this general idea that the improvisers were not completely in control of their own choices, and that there was no thinking involved. So Kessler, a trumpet player, described that he's not making any choices. He says that that there's no thinking involved, and that notes just come out the moment it's happening. Darrell Anger, a jazz violinist, says something slightly different, but in the same vein, where he says, I'm kind of watching my hand crawl around the violin, and it's like the brain picks up on something I'm doing. But what's interesting here is it applies that it may have already happened. And these accounts align very well with this idea of automaticity that has been pointed out before. This was after this, I collected this study. So in his amazing book, Berkovich talks about this creator-witness phenomenon. He interviewed classical improvisers improvising in the Western classical tradition, and they also described this idea of their fingers kind of moving along on their own, and they're kind of watching their own fingers. And similarly, in his account of his own learning, Sudnov describes when he gets to the advanced stage of learning to improvise in the jazz style, he describes how it's like watching my fingers do their thing. So the basic idea here is that there's some automaticity. It's related to skill level, and this could align with the flow state as suggested by Arne Dietrich, where he says that flow state, a period after your skill is highly practiced and you are relying on your implicit systems knowledge base, which seem to align with this description of the artist level improvisers as having this idea bank. So what is the idea bank? One idea is that the idea bank is a collection of licks that you have played before. So in order to look at that, to see if there indeed are repeated licks in extant improvisations from artist level jazz improvisers, I analyzed a corpus of Charlie Parker solos, and I looked at the interval decks. So here's the beginning of a solo by Charlie Parker on Donna Lee, and if you look at this small pattern +2, +2, +1, -1, you could then take these numbers and you could I used a moving window looking across the whole corpus to see if that lick indeed came again, or was used again. And I found that in the full corpus, this was 46 solos, that indeed this lick -2, -1, -2, -2 occurred quite often, which you may recognize as being a descending major scale, da, 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 and descending chromatic scale. Interestingly, if you look a little further down, you can see that ascending licks appear to have, common ascending licks appear to have a major and minor thirds in it. So anyway, basic idea here being that licks may be one of the functions of one of the mechanisms that artist level improvisers use when they improvise. Indeed, I found that not only were there these very short licks, interval licks, but there was many instances of longer licks. Here are some examples of some 10 interval licks. So if licks is a way that allows, a process that allows artist level jazz improvisers to play, that promotes automaticity, would it be possible to modulate artist level improvisers' use of licks by modulate their attention? So the idea came for this dual task study, a study I worked on with my colleague at University of Texas, James Fidlon. And the basic idea here is that the secondary task may alter the improvised output so that it contains more patterns, because if you can't even attend to your own improvisation, then you are forced to rely even more on this automatic process for generating notes. So what we did was we had very experienced jazz pianists, and we tapped them as they were playing blues improvisations, and we compared that to conditions where we didn't tap them. And what I mean by tap is literally they had to count taps. The secondary task was they had to count taps on their shoulders as they improvised, and then they had to tell us how many counts there were on one of the shoulders, ignoring the other one. And so we looked at the improvisations that they did while they were being tapped and compared them to conditions where they weren't being tapped. We also modulated the key to familiar and unfamiliar keys. And indeed, we found that when they were being tapped, they used more patterns, which seems, again, to support this idea that pattern use is related to automaticity. So if automaticity is a feature of improvisation, is that something that we could see in electrophysical signals from the brain, EEG signal, if we were to compare improvisation to a control condition? And Charles Lim's lab and Frederick Jolin's lab at Karolinska previously have looked at contrast between playing artist level and different types of improvisers playing something pre-learned and playing something improvised, and identified changes in brain activations. So we started with an EEG study. This was music students, not jazz experts, but they came in having memorized these 4 different melodies to be played on a piano. And so they were both asked to play them, and they were asked to imagine them. And here is average slow waves, just to illustrate. So they heard a metronome. 0 here is when they're supposed to start playing the melody, but they started hearing the metronome and they were told whether to imagine or a melody, imagine an improv, or play a melody or play an improv, and the melody, of course, was dictated out of those 4. So they heard that 3 seconds before, so we analyzed data 3 seconds before, as you can see here. The metronome clicks at 700 milliseconds every 700 milliseconds, and you can see that note presses are you can see note presses and metronomes are related to these spikes across the 8 notes. Looking at time frequency analysis, interestingly, we found that in the playing condition, the play melody condition, we found an increased wavelet power in the alpha band, which is slightly different from previous studies that have looked at alpha and creativity, where alpha is related to creative thinking. This seems to be different, maybe due to the paradigm. The idea we put forth in the paper is that as you start playing this learned melody patterns, you are actually inhibiting responses from the outside so as to not interfere with this melody that you already planned, this motor pattern you've already planned, and that the alpha, which has been associated with inhibition of outside influences, that's what you see here, that you know, maybe visual and maybe even auditory, if they're looking at their hands, influences are inhibited in order to play the melody correctly. Looking at EEG sources, we identified sources, 5 different sources, and then we did, so here looking at connectivity, specifically Granger causality, you see significant decreases in improvisations compared to pre-learned between the supplementary motor area, left inferior parietal lobule, and left superior frontal gyrus, which is an interesting result that could relate to this idea of automaticity being increased with the top level control coming from the superior frontal gyrus being less influential in the improvised condition. So which are the brain areas, or maybe even networks, that are related to these automatic note generation processes and this potentially the sketch planning process? Roger Beatty suggested in 2016 that note generation comes from a bottom-up process that may be underpinned by the default mode network, which has been associated with creativity and these bottom-up ideas. But on the other hand, you need to make sure that the idea fit the current context. In other words, a top-down control, cognitive control type process. So it may be that advanced improvisers use this sketch planning process as one way of sorting and deciding which lick is appropriate at a particular time. Anyway, so moving more into networks, we did an fMRI study where we also used this pre-learned and improvised contrast. Previous studies have mostly, if not exclusively, used pianists, and that's because you can adapt a piano to an fMRI scanner. So we decided that we wanted to use improvisers that scat sing in the scanner, because scat singing, and I am trained as a jazz improviser, and have used scat singing quite often in classes and in practice to learn new tunes. I can't help it myself. I have melodies running in my head all the time. I scat sing them out sometimes. Sometimes I just hear them. So again, we kept this idea of imagining improvisations from the previous EEG study. So this study had 24 experienced jazz musicians, not just pianists, but different instruments. They got to play. They played over a blues progression, or played, sang over a blues progression. So they came into the lab knowing these 4 common bebop blues, what we call heads. And so the instructions initially said, you know, this is the head you're going to sing or imagine. It gave a 2-measure count. And then the idea here is that you sing this twice or imagine it twice, and then you go into improvisation directly afterwards, like you would in a jazz performance. So let's try to listen to these. So this is a little bit of a song performance of a melody. And here's an improvisation. And if you are a trained improviser or a jazz listener, you can hear that this improvisation follows the chord progression. So even though there are no chords, I can hear that this gentleman is switching from the 1-1, so 1-2-5-1, 2-5 to the 4 chord. I can hear that change in his improv. And I was listening to, and we have recordings from nearly all, unfortunately we lost a couple, but we have from nearly all the improvisers, and made sure that they indeed followed the progression in their scat singing. So different from the 2008 famous Limp and Brown study that found a combination of activations and deactivations during improvisation, we found increased activation in inferior frontal gyrus, supplemental motor area, left premotor, and cerebellum during improvisation as compared to pre-learned. Interestingly, only the inferior frontal gyrus activation survived if we only looked at half the trials, meaning the vocalization trials, but 3 of the activations survived if we only looked at the Imagine trials, which I find kind of interesting. But here, the most interesting is that when we looked at functional connectivity, and again here we looked at Granger causality, we used seed regions that were determined from the regions that had differences in activations in the contrasts, and looked at connectivity between those 4 regions. And just like with the EEG study, we find more connectivity in the pre-learned compared to the improvisation condition. So to summarize this study, more activation in Broca's area, specifically supplementary motor, cerebellum, less functional connectivity between frontal and supplementary motor areas during improvisation. The current study that's described in the abstract this is based on the same data. It's a reanalysis of the same data. Here we used this unsupervised algorithm that is implemented in a software called GIFT, designed by the lab, the Trends Lab at Georgia State. We found 39 independent components representing different resting states networks. And here you see the main networks on the right. Most importantly for the current discussion, the ECN, the Executive Control Networks, which for 5 of our independent components we labeled as being part of the Executive Control Network, and then the default, the dorsal default mode network, and the ventral default mode network. And over here we see an analysis where, on the left, where there's changes between the 4 different conditions in connectivity between those areas. Here, statistically, and it's important to note that head motion is regressed out, something that was just asked by us, by our reviewers. So to me, it is really interesting that to look at the Executive Control Network, and what you see here is that connectivity in red is higher during the pre-learned condition than during the improvised condition. But what's really interesting is that you see this both in the imagined condition and in the vocalization condition, where this pattern of mostly less connectivity during improvisation holds between those 2 modalities, which I find really quite fascinating. We also looked at some graph theory measures within some of the nodes, and if you remember, the clustering coefficient is a measure of how much the neighbors are connected within a network. And we found that during the vocalization improvisation conditions, 3 of the ICA's independent components indeed showed a lower clustering coefficient than in the other conditions. So to summarize, if we compare connectivity between networks, in the pre-learned condition, we have higher connectivity among ICA independent components within the Executive Control Network. We have higher connectivity between the Executive Control Network and auditory, ventral default mode, dorsal default mode, language, primary visual, salience, and high visual areas. And this is less in the improvisation condition, which seems to align with this idea of attenuated top-down control during improvisation, which could, coming back to the beginning here, align with this described feeling of automaticity that artist-level improvisers have described. And this idea of automaticity, this feeling of automaticity of things occurring without you consciously thinking about it, has then again been linked with this idea, this flow state idea, where you are completely immersed in a activity without evaluating it, without being engaged in evaluation of that activity. We have also done structural analysis here. We use diffuse attention imaging to look at our sample of artist-level improvisers and found changes in the structural connectivity as compared to a control sample of non-musicians. We'd like to do that again with a sample of non-improvising musicians and see there's a change here. And another area of interest is analyzing the actual output from improvisers, and hopefully you saw the talks in the previous hour by Klaus Freidler, who talked about a sequencing bias similar to language production. If not, I highly recommend that you go and check that out. And we are working on analyzing improvisations using network analysis, looking at actual output and creating a network from existing improvisations in this study that Hannah Mersel also described in a talk previously that I hope you will go back and look at. We used the Weimar database to create a network and showed that that you can use network measures that align with participants' ratings of similarity. So this is the end of my talk. Thank you so very much for listening. Thank you to my different collaborators. Victor Vergara is the one that did the main analysis, the latest connectivity analysis with the ICA. Victor and Robin Miller are currently collaborating with in a trends lab at Georgia State. We are hoping to do more analysis of this data, maybe moving into dynamic functional connectivity. So thank you so very much.
Thank you very much, Dr. Martin, for this interesting talk.
Thank you.
We already have some comments and questions in the chat, so I'll read some of those. Professor Dr. Partha says, your imagined connectomes show more inhibition than the learned model. Please comment.
Yeah, I think that was when I was talking about the EEG study, and it is EEG and not MEG. I would think that that would fit with this idea that, you know, you are trying to attenuate external stimuli while you are singing something pre-learned. You have this melody you're going to sing, and maybe listening to yourself will mess yourself up because you've already planned it. But what's interesting is that we've seen creativity being related to the alpha band. So it's opposite but that we've seen in other creativity studies. But the famous Fink study with dancers saw increased alpha in a more creative dance condition, imagining a more creative dance condition. So this is opposite, but of course that was not within a time constraint. So I don't know that you can really compare those two paradigms, but thanks for that question.
Okay, thank you very much. Also from Professor Dr. Partha, was it an MEG study? As a routine EEG would not have the spectral power of alpha analysis. Was not sure from the EEG slide you showed. Please explain.
Yeah, and I just think I just answered that. It was EEG. When it comes to spectral power, that's something we'd have to check with my collaborators. I am the music educator and wouldn't know how to do the statistics. So that's a question for Dr. Tamala, who supervised the analysis.
Thank you. We have another question from Shush Ruta. I hope I pronounced it correctly. Was there any difference in the level of expertise of musicians? Was there a possibility that a musician with greater creativity could imagine the improvisation and was not able to actually play the improved version?
That's a great question. So this is something that I'd love to look into more. So in the sample of the FMI study, which is, you know, that's the sample we use both for the connectivity of resting state, the same sample for the DTI, and then the FMI. So that's all the same 24 people. They were all expert level, and we are not able to differentiate according to their skill level. It's hard to judge from these singing recordings to do a measure of skill. In retrospect, maybe we should have had them, play an instrument outside of the scanner. But I think that, I forget what we said. They had to have, recordings, and they had to have improvised for a number of years, and so. But I would love to do something with a different level different skill levels in improv. Now, there is a study by Pinho out of Olean's lab that's looking at skill level and improvisation. I think it's a 2014 or 2016. The thing about being able to imagine something that you can't play, that's a really interesting question, because all you got to do is play an instrument that's not your main instrument. And I'm a jazz violinist. I can play, many of the things that I imagine on the violin, but then if I was to play it on the piano, which I can play a little bit, it doesn't come out. And so that's, I think, an interesting issue that I don't know that has been explored experimentally. This idea that you can imagine something that you can't play because your motor patterns are just not there. So that's something that we'd love to explore more.
Thank you very much. We have another question from Emma Allingham. Thank you for the fascinating talk. Do you think that spontaneity and interactivity in performance can occur in this automated way? Or do you think that conscious control is intertwined with automatic processes, such as in the mesh theory of motor control?
I don't know that particular theory. I'd love to learn more. However, I would argue, as a trained jazz musician, that one of the main reasons for learning licks that allow me to automatize my improv is that so that I can focus on interaction between other musicians. So if you read both Berliner's qualitative accounts, Thinking in Jazz, and also Ingrid Monson's fascinating book, most expert jazz musicians will say, my goal is to communicate with my fellow musicians. That's really what jazz is all about, is this interactivity. And I don't think that would be cognitively possible if we had to exclusively focus on our own output in order to create it in the first place. But that's also something that, we've gone from looking at intervals, to improvisation, which is such a complicated thing to look at in the first place, and then to look at interactivity. The closest I think we've gotten is Charles Lim's lab did a study where they were he was playing on a piano and interacting with somebody in the scanner. I think that's a 14 study also. I forget the first author, but it's fascinating. And they saw some, if I remember correctly, some brain activity related to, Donnet, I think that's correct. Somebody, thanks Keith. They saw some activity that I think was related to some language areas that are also related to connectivity and interaction. Anyway, I hope I answered the question.
Emma says thank you.
Okay.
And we have Alex Billing. He says comment rather than question, possibly relevant to understanding the first EEG results you showed. The slow potentials or baseline shifts seem to differ between conditions, as did alpha power differences. There is a work by Nikulin showing that these phenomena may be related.
Cool. We'll check that out.
And Elke Lange, thanks a lot for the interesting talk. I wonder whether musicians will change their state from automatic control back and forth. Is this what you will look at when analyzing dynamic networks?
Yes. So in this paradigm, we have them improvising for about 32 seconds on average, and then and pre-learned also about 32 seconds. And of course, some of the newest data, there's some data coming out from Peter Wust's lab, is that it doesn't mean that the connectivity across those 32 seconds of improv is the same. There's probably different processes happening as you're improvising, according to, you brought up Roger Beatty's, this idea of a bottom level up process presents potential ideas to play, and then a top down process selects the best idea for the current context. I mean, maybe we can see a change between default mode network and executive control network alternating during the improvisation condition, and that's something I would love to look at, by reanalyzing this data once again using dynamic connectivity. Yeah.
If I may pose a question.
Sure.
I've seen consistently alpha participation during imagery. So I was wondering if you have any comment, because it's frequently mentioned as an inhibition process. But I'm not sure if it would be the only explanation, because it's always there, or at least consistently, participation of alpha during imagery tasks, different tasks. So maybe it has something to do with the process itself, not just by inhibiting.
Right. Well, in the EEG study, of course, we compared imagining a pre-learned, playing a melody and imagining an improv. So the part that's imagined should be canceled out. But I think it's very possible that just the process of imagining means that you have to kind of disregard external stimuli, because otherwise you can't imagine. So without knowing the literature really well, that would be my hunch.
Thank you very much. Professor Andrea Halpern says, possibly could cause a shift from control to automatic by using your prior manipulation, by subjecting them to a secondary task, possibly and at unexpected intervals.
Yeah, that's a great idea. So maybe, I don't know if we could do a secondary task manipulation in the scanner. How cool would that be? Yeah.
And Tahenechovics, I am wondering if differences between imagined and singing performances have to do with instrumentalists. During singing, different motor tracks involved, but in imagining could be activation of motor patterns related to the instrument.
Yeah, that's also very interesting. But again, when you're looking at, when we are subtracting imagination improv from imagination pre-learned, the imagination part should be subtracted out. That's the old paradigm with contrast, right? We try and find two conditions that are exactly the same except for the thing that we're looking at. But does motor patterns play a role, and do they play a role when you're singing? I think that's an interesting idea. I have to think about that some more, because of course the motor patterns needed to scat sing would be different from the motor patterns that an instrumentalist would need to play their instrument. So then you could ask, and this may be a question for Andrea, is do you think that they are actually imagining their own instrument when they're scat singing? So, that's an interesting question. That's the fun of research, right? That the more answers we have, the more questions we have.
Indeed. And we have another question from Professor Partha. Did not follow the default mode salience network diagrams in impro versus improvise and learn playing. Please explain.
Yeah, I just pulled up my figure to look at the salience mode differences in pre-learned and improvisation. So it's one of the slides, and I'm seeing that the salience network and the ECN are more connected during pre-learned than improv. If you're looking at the ventral default mode and the salience, there's both some higher connectivity and less connectivity between the two conditions. So I think Beatty's idea about this change during creativity between the default mode and the executive control again, a default mode may be presenting ideas and the executive control selecting the ideas. I think I think somebody has put forth that the salience network is the one that controls the switch from one to the other. Anyway, all stuff to think about. I don't think that we covered the salience mode in detail in the paper, if I remember right. So there's a paper in review. I don't think we put it up as a preprint, but these latest results are in review, hopefully coming out soon.
Great. And as there are no more questions, Dr. Partha has a lot of them, so I'll read them. He says, which is more energy consuming, learn or improvise playing from your hypothesis of fMRI, EEG, and connectomics DTI? Has there been a longitudinal study in musicians to see serial changes? Which areas?
Oh, that's one of those where I'm going to say I don't know, and I don't know what. So I think I saw the questions, but I can't see it right now. You said energy? What was
energy
the term?
Consuming? Yeah.
Yeah, energy consuming. I'm not sure what is meant by energy consuming in this particular context. If you want to talk more about what that is, energy consuming. I mean, yeah, not sure. Sorry.
He says more blood flow on fMRI.
Oh, okay. So we saw in our fMRI study higher bold signal in improvisation compared to pre-learned, but that's different than what Limp and Brown saw in some areas. Now, what I didn't show was if we lower our statistical threshold enough in our fMRI contrast, eventually we do see some deactivation, but I don't know if that's error. But I think that the basic answer is it depends. It depends on which area you're looking at. If there's higher or there's lower energy or bold signal in the two condition, it depends on which area.
Okay, I think it's time to wrap it up. Thank you very much, Dr. Martin. It was really exhilarating talk.
Thank you so much,
everyone, for being here. And we have a concert in a few minutes in the next hour, so you're all invited to go there, and maybe afterwards the deck party.
Thank you.
Thank you very much.